Formula One race cars are fast and sleek. They zoom around the track at extraordinary speeds. But how do these cars go so fast? And how do the drivers stay safe? To get your head around the finer points of Formula One engineering, you'd need a few years' worth of specialized qualifications up your sleeve. But when it comes to key factors of what makes a Formula One car work, we can go over those points easily enough in this video. So stick around till the end, and don't forget to hit subscribe to our channel if you still haven't, and keep the notification bell on to ring you on our future updates. For now, let's get right into it. The heart of a Formula One car is the chassis, the part of the automobile onto which everything else is bolted and attached. Like most modern cars, a Formula One car features a monocoque construction. Monocoque is a French word meaning single shell, which refers to the process of making the entire body out of a single piece of material. Once upon a time, that material was aluminum, but today it's a strong composite like spun carbon fibers set in resin, or carbon fiber layered over an aluminum mesh. The result is a lightweight car that can withstand the enormous downward-acting forces that are produced as the vehicle moves through the air. The monocoque incorporates the cockpit, a strong padded cell that accommodates a single driver. Unlike the cockpits of road-ready cars, which can show great variance, the cockpits of Formula One cars must adhere to very rigorous technical regulations. They must, for example, meet minimum size requirements and must have a flat floor. The seat, however, is made to fit the driver's precise measurements, so his movement is limited as the car moves around the track. Before 2006, Formula One cars were powered by massive 3-liter V10 engines. Then the rules were changed, specifying the use of a 2.4-liter V8 engine. Even though power outputs fell with the rule change, Formula One engines can still produce nearly 900 horsepower. To put that into perspective, consider that a Volkswagen Jetta's 2.5-liter engine produces just 150 horsepower. Of course, the Jetta's engine is probably good for at least 100,000 miles or so. A Formula One engine needs to be rebuilt after about 500 miles. Why? Because generating all of that power requires that the engine run at a very high revolution rate, nearly 19,000 revolutions per minute. Running an engine at such high RPMs produces an enormous amount of heat and puts a great deal of stress on the moving parts. The fuel that powers such an engine is not the typical unleaded gasoline you pump at the neighborhood Exxon, but it's similar. Small quantities of non-hydrocarbon compounds are allowed, but most power-boosting additives have been banned completely. All in all, Formula One teams use about 50 different fuel blends, tuned for different tracks or conditions in a typical season. Each blend must be submitted to the FIA, the sport's governing body, for approval of its composition and physical properties. When coming to the body, the first thing you will notice are the front and back wings. The front wing is one of the most important parts of an F1 car. It is the first part of the car to encounter the oncoming airflow, which makes it fundamental for aerodynamic performance. The wing has two main functions, one to create downforce, the other to slip the oncoming air around the front tires so they don't get held back by the force of high-speed air. For downforce, this is achieved with end plates. When the air comes in contact with the wing, it slides over the top. The end plates are there to prevent the high-pressured air from spilling back underneath. The weight of this air pressed on the end plates drives the car down onto the tarmac, providing drivers with better handling, cornering, and more responsiveness. Next up, we have a diffuser. The diffuser is designed and engineered to create downforce and provide stability. It's positioned on the rear of the floor with a flared opening for sucking in air, moving it through smoothly, and creating a low-pressure zone. This low pressure works to enhance the force of the air pressing on the top of the car, increasing downforce so drivers have more control when tackling apexes. The job of the diffuser is to reduce the flow of turbulent air from beneath the car for improved performance. Up next, we have side pods. They play an important part in packaging the car as tightly as possible, housing the radiators and manifolds compactly, minimizing drag. The main radiator inlets are positioned on either side of the car and must accept enough air to provide sufficient cooling to the power unit. Without enough cooling, the engine and its other components are liable to overheat, losing performance, and potentially failing. The inlets have to be carefully designed to be as efficient at cooling as possible while remaining as small as possible, and must also be positioned to be fed with the maximum amount of clean air. The suspension is the link between a car and its wheels, dictating how it reacts to the road and to the driver's inputs. On an F1 car, teams are allowed up to 6 structural members per wheel, typically made up of 2 double wishbones, the push rod or pull rod, and a steering arm or track rod, depending on if it is the front or the rear suspension. Teams often employ pull rod suspension at the rear of the car, and in 2019, all 10 teams on the grid employed push rod suspension at the front. When the wheel moves up in response to the track, the spring is pushed into compression by the push rod. A pull rod will be mounted in reverse, and the preference between the two is simply a result of a car's packaging. Most setup work done on an F1 car will be to the suspension, and teams can make changes to the camber, toe, spring rates, ride height, and a whole host of other properties to suit a certain track. When it comes to braking, probably the most crucial rule on F1 cars is that anti-lock braking systems, ABS, found as standard technology in regular road cars, is not permitted when racing, meaning that drivers have less control and need to tackle longer stopping distances than standard road cars. Safety is a high priority in motorsports. Formula One has seen many tragedies in its early days, with many casualties that included drivers and spectators as cars crashed at high speeds. Engineers researched using the latest technology to build safer cars and gear for drivers. This includes helmets along with head and neck support, the purpose of which is to protect the driver's vertebrae and collision of head to the steering wheel in case of an accident. The clothing of F1 drivers is designed to protect them from fire accidents in case of a crash. It is a multi-layered suit that matches specifications of NASA. Nomex is the latest fiber material brand used to build suits for F1 drivers. The suit undergoes thermal testing. It is fire-resistant and lightweight. The suit is also worn by the pit crew. The outfit is washed and dry-cleaned multiple times before undergoing tests. There are 2 handles on the shoulders of the suit so it can be strapped with the seat. This allows the pit crew to pull the driver out in one piece with the seat during a crash to reduce injuries and make sure the driver is safe and sound. Well, there you have it. The complete review of how the mighty F1 car works in 2022. If you liked the video, then do like it and subscribe. And we'd love to hear your thoughts in the comments section below. Thanks a ton for watching, and we'll see you in our next video. Until then, have a nice day.